Back once again. Today we're going to be talking about the environment and pollution. So some issues takes up a lot of discussion, debate in the country and around the world. And there are many different kinds of forms of it, many different causes of it. Well, part of concerns around environmental pollution involve water. Water, of course, is central to life. Simple H2O. As humans need fresh water to live, I said the water cycle is essential for our existence. Hydrologic cycle. Basic system of evaporation, condensation, and precipitation. Water draws, water forms, water falls. Very simple system. There's many differences in water supplies. There's plenty of fresh water for humans to use, but it varies on a local scale. Some areas may have too much, some may too little. Droughts dry up some sources. Deserts have very little water. Also, issues with pollution that may make water unusable. And remember, precipitation varies from time to time, place to place. Some areas may get a lot of rain, but that may only be in a very narrow time of the year. Some areas may get very little water at all. There's some areas in the Andes Mountains that doesn't rain for years sometimes. And there's some parts of the world where it rains every day. It differs greatly. It varies from time to time, place to place. Now, irrigation for agriculture that is 2/3 of water use around the world, fresh water use. Developing countries, that's about 90%. Strong agricultural economy, still trying to develop their efficiency. Now, industry take up about 21% around the world. Because depending on the industry, they will use differing amounts of water. Various manufacturing processes. Households and cities, they use all the rest that is for residential drinking. Now, since 1950, water use has tripled around the world. Some countries, they have what they call a water deficit. It is not enough water to for the needs of the community, needs of the population. Middle Eastern and North African countries currently use more than their renewable share. That is, what water is available, they're using faster than they have available. Is using not only what they get from precipitation, but from ground-based sources. It means they don't do something, they're going to run out. A very serious situation on their hands. Actually, Israel, because with control of the Golan Heights, it essentially has control over the Sea of Galilee, which is the largest freshwater source in the region. And that is another point of contention between Israel and Syria. The Yellow River and the Colorado Rivers. So much water is used, so much water is pulled out for residential, agricultural, or industrial uses that the rivers run dry before they reach the ocean. They should normally just drain out of the ocean, just simply there's such dry. Lake Chapala, for example, the largest body of fresh water in Mexico, has lost 80% of its intake since the 1970s. Again, that is because water is being diverted for other purposes, for residential use and for agricultural use. Another example of this, how water diversion has caused serious problems, is the Aral Sea. It's the fourth largest natural freshwater lake in the world. But because of irrigation in the area, was diverting water into the Aral Sea. The Aral Sea just started drying up. About 90% of it's gone now. There have been some efforts in the past few years to try to divert some of this irrigation water back into the Aral Sea, but the damage has been extensive, probably irreparable. But once was because with the Aral Sea, as all the water in the sea dried up, you have all this exposed soil and all these salts and minerals that have now exposed to the air, and they are blowing around, causing all sorts of problems with agriculture in the region and with breathing because of all the dust and pollutants down in the air. And you have famously in the United States the Oglala Aquifer. Huge underground reservoir of water across the Plains states, particularly Nebraska and Kansas. About a quarter of all groundwater used in the United States comes from the Oglala Aquifer. But it's been greatly depleted because of industrial use and agricultural use. It's about 8 times faster than it can be restored. This has also been an issue of contention. Now, how can we reclaim fresh water? Remember, 2/3 of the earth is covered in water, but a lot of it is undrinkable because it's salt water, ocean water. Now, you get desalination has been proposed, and it does work. It's a process which salt can be removed from water. But the problem is it's very expensive and very energy consuming. And also the idea of channelization. Which is similar to, which is what we're talking about here, diverting water for human needs. Again, this is also expensive, and can cause problems on its own by diverting water from one area. It could be damaging an ecosystem, damaging agricultural systems in another area. But the more arid parts of the United States, particularly areas like Texas and Oklahoma, channelization is effective in many ways. Many man-made lakes have been created by damming up one end of a river in a little valley, let the water fill in behind it, creating man-made lakes. In fact, nearly every lake in Texas and Oklahoma is a man-made lake. But all is feeding into the question of environmental pollution. Scientific definition of environmental pollution is the introduction into the biosphere of materials that of such a volume that cannot be disposed of through natural recycling processes. Introduction of materials into the biosphere in such a volume that nature cannot process it quickly. Now, nature is very good about cleaning up after itself, but sometimes it takes a very long time to do it. It takes centuries or even millennia for it to happen, but it can do it. But a lot of pollution brought into an ecosystem, it can be disposed of fairly quickly by nature, washed away or blown away or however else, or just by simple decomposition. Um, but sometimes it's materials of such a nature or such that they cannot be broken down quickly. Radioactive materials, for example, can take centuries to decompose and decay to a safe level of radiation. Certain types of chemicals can't be broken down easily. That is, nature can take care of it, but it will take centuries for it to be completely neutralized. And that by itself, most pollution is artificial, but there's such thing as natural pollution. There are some things brought into the ecosystem that by nature that can cause pollution. Example, beavers building a dam, they produce a lot of waste that can't be disposed of just by nature cutting down all those trees. There's a landslide or flood. Water is mixed in with all sorts of soils. It makes it basically undrinkable for a lot of animals. It takes a few days for it to wash out. Um, but artificial pollution, that's the big problem here. Man can be messy. Now, pollution itself means that water or some other resource has been so altered that it cannot be used for a specific purpose. Drinking, agriculture, and stuff, but could still be used for other purposes. Manufacture and cleaning materials, so forth. Example, the idea of what we call potable water. It means drinkable water. Um, some types of water, they're contaminated. They cannot be used for drinking water, but still could be used for something else, manufacturing or Um, Even, for example, here in El Dorado, they use what they call a gray water sometimes to water the golf courses. Gray water is wastewater that is um, that can't be isn't safe to drink, but is safe to use on grass or sometimes even agricultural purposes. To contaminating to the point it's not drinkable, it's a serious problem. For example, why there's so much concern about oil pipelines going through areas near aquifers. Oil pipelines, they do tend to leak. What happens if it leaks into an aquifer? It means that groundwater is completely contaminated and therefore unusable for drinking water, unsafe for human consumption. Like I said, natural causes of pollution, animal waste, natural disasters, such. But there are natural balances in there that can restore the restore water to and a habitat back to its original state, which takes time. Sometimes takes a very long time. Give an example here: carbon dioxide. It's naturally occurring, but it can be considered a pollutant in certain circumstances. But excess carbon dioxide, for example, can be absorbed by plants and some minerals, um, maintaining a natural balance. But if too much is released, um, such as being carbon dioxide being released through industrial manufacturing processes, that can overwhelm the natural process, overwhelm the natural counterbalances. Therefore, carbon dioxide keeps building up more and more into the atmosphere. Now, there are four major contributors um, to pollution: cultural, industrial, mining, and residential. And all these sometimes are a lot of chemicals being used just to maintain for certain purposes. Mining, they use a lot of chemicals to get the particular ores. Sometimes a lot of water. And there's a lot of waste that goes into mining too, separating the dirt and rock from the residential purposes. There's a lot of trash being lying around. Industrial purposes and agricultural purposes, a lot of chemicals used in that, which overwhelm the natural counterbalances. And while chemical fertilizers can produce increased yields, increased food production, the runoff from it can contaminate the water supply nearby. Now, you also have the idea of point sources. Specific locations where pollution originates, and non-point sources. Pollution that is more diffuse and more difficult to contain. Certain types of water pollution can be non-point source. It's just simply gathering from different areas and gathering into a larger river or lake or ocean, and uh, creating more and more larger and larger problem. Uh, Air pollution means the air moves about back and forth. Cities, a lot of problems with air pollution, for example. It's not just necessarily one source that's causing it, it's several different sources all combining there into that immediate local area. Off the Gulf, off the coast of Louisiana, off the Mississippi River in the Gulf of Mexico, is what they call a dead zone because fertilizers used upstream the Mississippi, Ohio, Missouri River valleys. It gathers these farms and kind of starts moving downstream to finally get to the point it's off the coast and the ocean, but it's kind of collect so much there that basically it's killed a lot of the animal life there. Made it very difficult for it to survive. Now, pollution occurs as a consequence of any human activity, um, even absent human activity. That is, pollution happens. It's part of existing. Animals pollute, but the question is how much of it is caused, and how nature can absorb it. So the question: why control it? Well, you have several reasons. Water pollution, waterborne pathogens, such as from agricultural runoff or sewage, contaminates water. Manure from animals, sewage runoff, contaminates water, causes disease, and around the world, this disease has killed millions of people every year, particularly children. Amoebas and bacteria in water um, cause all sorts of diseases. It's estimated probably 2 to 3 million people die every year from drinking contaminated water. Cholera, diarrhea, typhoid, and so forth. Now, with agricultural pollution, so I divide this into three main sources. One, fertilizers. There are natural fertilizers, but they are also polluting. Animal manure, for example, it's a natural fertilizer, but it's kind of hard to spread it evenly. And yes, it contains a lot of bacteria that can contaminate a water supply. The chemical fertilizers, made a lot of chemicals, can be hazardous for people's health. The fertilizers, it adds excess nutrients to waters, among other things. So you get the idea of eutrophication. Eutrophication is the enrichment of waters by nutrients. Now, why is that a problem? See, fertilizers increase algae and plant growth in water, which means more algae growing on the surface because of these fertilizers, which encourage plant growth, means it's blocking sunlight from getting into the pond. Organisms live near the surface, they depend on this sunlight as part of their biosphere. That cause these organisms underwater, deeper into the water, to die. And when they die and decompose, the level of dissolved oxygen in the water decreases, thus killing other fish and animals in the water. It is less for them to eat, less for them to breathe. So it affects all these animals. You see the process of eutrophication. About 50% of lakes and reservoirs in North America, Europe, Southeast Asia, and about 40% in South America, 28% in Africa. So it's seen in basically about half of all lakes and reservoirs here in the Americas. You also got biocides. Certain types of insecticides, herbicides, and so forth. In order to maintain high crop yields, herbicides are used to get rid of unwanted plants that could be taking nutrients from the main crop you're trying to use. Pesticides, you're trying to get rid of certain types of insects that could damage or even destroy crop. Problem is, highly poisonous. Put that in the water. Water can sometimes break it down. The water can sometimes dissolve it and dilute it, but not always. For example, there's a particular herbicide called chlordane. Much was spilled into the Colorado River near Austin in the 1970s, washing it into the Town Lake area in downtown Austin. Problem, chlordane cannot be dissolved by water. So it sank down to the bottom of the Colorado River and the Town Lake, and fishing there basically is forbidden because the fish are all contaminated with chlordane. That's just one example. But sometimes with these chemicals, the effect isn't immediately known. DDT, for example, used in the 1940s on into the 1960s. It was a particular type of pesticide designed to kill mosquitoes, which are spreading diseases like malaria to people in many areas. The problem was DDT didn't break down very easily. So through the process of biomagnification, organisms ate larger organisms that had been contaminated or had died from exposure to chlordane, to a DDT. But it meant just more and more, as they ate more of these creatures, organisms, it meant more and more DDT was in their bodies as they're eaten by larger organisms, and larger and larger. And that started working its way all the way up to the food chain. To the point where for one particular species, the bald eagle, our national bird, very symbol of our country, was nearing extinction because DDT contamination was causing birth defects. Eggshells were becoming very brittle, breaking open before the baby birds were ready to hatch. And there's there were issues of cancer and other health issues reported with it. So DDT was banned in the United States. So sometimes health effects aren't immediately known. And sometimes, like I said here, they don't break down easy or kill animals and fish, can cause cancer in people. Latent health effects in people, we may not know about it initially, or it doesn't break down in nature. 3, animal wastes. Like we discussed, wastes that are filled with bacteria that can contaminate a water supply. Now, in the United States, there are about 3 billion tons of manure produced every day. That's a lot of manure. No way to dispose of all of it, and much of it is used as natural fertilizers. Some farms have large feedlots that are collected into containment ponds and used as a water fertilizer for the fields. Basically, just a um, big old pit filled with manure and urine and all sorts of. It doesn't smell good. Um, um, and But a lot of these are built with earthen dams. So what happens when it rains too much? These earthen dams break or it overflows. That's pleasant, isn't it? Which means that the runoff from fields means it overflows into water supplies, and even the runoff from fields can seep into the water supply. And so there's a particular bacteria called Pfiesteria piscidia. Mass outbreaks were reported in areas of North Carolina and Virginia because coming from these pits where water is overflown and contaminated the water supply. And particularly common with from large poultry and hog farms. It's killed millions of fish in rivers near these large farms when these, because of the contamination of animal waste into the water supply. I have a lot of bacon and a lot of eggs, but no fish. Brings us to the idea of industrial water pollution. Industrialization. Developing nations, the amount of industrial pollution is roughly equal to that of agricultural pollution. The industries discharge organic and inorganic waste into water. Now, the difference between organic and inorganic. Um, Organic contains carbon. Inorganic does not contain carbon. Carbon is a very useful, very versatile element, can be used in all sorts of different chemicals, all sorts of different substances. Life as we know it is based on carbon. But that's, in fact, an entire field of chemistry is devoted to studying carbon containing substances, organic chemistry. In fact, it's considered a requirement for people entering into studies of biology and medicine because everything has, every organism has, every person has carbon. Well, discharging organic and inorganic waste into water. This can include toxic materials such as mercury and arsenic, or solvents and chemicals from repairs or other different processes. And sometimes it's from manufacturing, there's a spill off, especially in factories that aren't very efficient. Mercury and arsenic are highly poisonous, and that is sometimes a um, runoff problem from industry. Now, water it's a very simple molecule, very simple substance, but it's also very good at dissolving other substances. But the problem, though, is some substances cannot be dissolved in water. Water, for example, can't dissolve oil, benzene, byproduct of many chemical processes, rubber, or gasoline. But water getting into your gas tank is still a problem, even though they don't dissolve each other. it can because water's in the system messes up the chemical processes involved with running your engine. Oil, highly viscous, very slippery substance, which means you can pour just a little cup of oil into a pond, and that one little cup here, about the size of your fist, you can end up covering an acre of water, completely ruining it for any kind of natural use or any kind of use for agriculture or people. And oil isn't broken down by water. What happens when water's on the surface, it can evaporate. But a lot of times it'll just sink down into the ground, through the water to the ground and or the shore, and contaminating the rocks and organisms live in those rocks. The nuclear industry has caused some pollution. Some radioactive wastes buried have leaked into the sea or the groundwater that is improperly stored or stored for so long that the containers have decomposed, and stuff finds its way out, finds its way into the groundwater. And the thing about nuclear reactors is they use a lot of water. It's used as a coolant. Pollution has a variety of effects. Organisms that can adapt may die. The water may become unusable. The waste may re-enter the food chain with varying effects on people and other organisms. Give an example here. Minamata Bay, Japan in the 1960s. A chemical plant would discharge large amounts of something called mercury chloride. Mercury chloride, HgCl. But the chemical plant is letting this out, and it was being released into the local water supply. Well, got in the water supply and eat into materials that fish were eating. Fish fed on these organisms were contaminated with mercury chloride, and these fish in turn were eaten by people. The result, because of this spill into this release of the mercury chloride into this bay, 700 people died, 9,000 people were made seriously ill. Deformities caused birth defects, deformities, and a disability for people because of the lingering illnesses from contamination from it. You have PCBs. PCB is a polychlorinated biphenyl. So you can see why I call it PCB. Polychlorinated biphenyls. It's a whole class of chemicals. They are used as lubricants in pipelines and various uses in electrical devices and transformers. Example, these big containers you see on electric poles sometimes, they're filled with PCBs. Very useful for industrial purposes, but very, very poisonous. Years ago, when some of these were being manufactured, many PCBs were dumped into the water, contaminating a lot of areas. led to a lot of laws involving water pollution, the creation of the EPA, the Environmental Protection Agency, by 1970. And the dumping of PCBs was being linked to birth defects, cancer, liver disease, immune system damage. Just so somebody could save a few bucks, a lot of people's lives were ruined, their health ruined. A lot of people died from this as they're exposed to these chemicals that were dumped into the water. And again, because of this, because PCB contamination of any water supplies, some states have banned fishing in lakes and rivers with high amounts of PCBs. And may not be able to fish there for a couple of centuries until it finally breaks down on its own. Oil. Millions of gallons of oil and gas are typically spilled into water every year, mostly by accident. But again, the problem, water can't break it down. Water comes undrinkable. It contaminates and kills organisms. Dawn soap, the dish soap, they have a very clever advertising campaign about how their dish soap is sometimes used by in decontamination scenarios where they have a bunch of animals that are covered in oil from oil slicks. They will wash clean these animals using this dish soap. And it works. It's safe. It's clean. It cleans up the animals, and they're as healthy as they can be afterward. Most cases. That's the idea of acid rain. This became a very big issue in the 1970s, 1980s. Now, water has a typical pH of 7.0. Our pH scale, that is a ratio of acidic to basic. The lower the number, the more acidic it is. Higher number, the more basic it is. Base materials like bleach has a high base number. But to say citric acid, hydrochloric acid, sulfuric acid, very low on the pH scale. Water, 7.0, it's neutral. Well, problem is for years have been releasing industrial waste into the atmosphere that in some cases it would cause these chemicals would mix with the water vapor in the air and make the rain slightly more acidic, which over time had a cumulative effect. It would start basically eroding and decomposing features on buildings like statues and so forth, but also too much of it could, because of runoff, could contaminate a water supply, turning it more acidic, making it more hazardous for animals to live in those rivers and streams. Give you an example here. Evaporation, but you also got your little factory here, smokestacks. That's mixed in with the evaporation. Some of the clouds that come down. Now you have various nitrous oxides, all different kinds of it. This breaks down into two nitrous oxide nitrogen dioxide molecules. Let's do water molecules. It creates two nitric acid molecules. Two of each, they mix around. Nitrous oxide plus water creates nitric acid. And of course, you got some helium, which extra hydrogen, which just spills out of the equation, at least in the atmosphere. Sulfur dioxide. 2 water plus 1 sulfur dioxide molecule creates H2SO4. Uric acid. Very powerful solvent. And of course, you got some hydrogen gas comes out of it too. And that's how you create acid rain. I mean, the rain, the fog, the snow. Now, these products can occur naturally, of course, particularly from volcanic sources. A lot of sulfur released in volcanic eruptions, which will produce sulfuric acid. Planet Venus, its clouds are mostly sulfuric acid. Very hostile, very nasty little planet. Among other sources. Now, this is not to say there can be so much of this released in the atmosphere that it's going to cause acid rain that causes it to dissolve on the spot. No, that's not it. This is a cumulative effect over time. That cumulative effect, it can have serious consequences down the line. I go to see old buildings in, for example, in old European cities or even some older American cities. They notice that these statues have kind of lost their sharpness. They've decomposed, they've kind of lost some of their features because of exposures to low levels of acids. But you have too much of it, what happens when it gets into the lakes and rivers and affects the pH balance? It can cause some serious problems, at least on a highly localized scale. Now, not all acids are bad. Your body naturally produces acids all the time. Your stomach is filled with hydrochloric acid. It has to have that so you can be able to digest food for your body to work properly. But it all balances out. Again, the question is what happens when that imbalance happens. You see serious consequences to that. But it's because of issues here like acid rain that more strict controls on air pollution were imposed in the 1980s and 1990s, slowing down this process. Thermal pollution. That's another issue. You have a lot of industrial processes produce these chemicals, chemical reactions, and the heating to produce certain chemicals. You have a lot of hot water. So what do they do with this hot water? Even if it's clean, hot water, you dump it into a lake, that can cause problems. Too much hot water causes the temperatures to rise locally in a lake or stream, which can, again, affect the plants and animals living in it. There can be a major disruption to plant and animal life, thermal pollution. Back to mining. Gold mining, for example, cyanide is poured onto low-grade ore in order to extract gold. Lots of cyanide is thus left over. Cyanide, which it's naturally occurring, but very poisonous. And a lot of this leftover cyanide is sometimes dumped into rivers. Mercury is sometimes used to separate gold from rock, usually in South America. Mercury, it is a metal. It's liquid at room temperature. To makes it very useful for many types of chemical and industrial processes, but it's very poisonous. Well, mercury used in mining, what happens to it? It's dumped in the water. Estimated about 100 tons per mercury per year is dumped into the Amazon River and its waterways. Mercury builds up over time and does not break down. And then residential uses. Household cleaning products, pesticides, sewage, and so forth. In the undeveloped world, about 90% of sewage is untreated, raising extremely high risk of disease. This is why so many of these poor countries have so many outbreaks of disease, because they haven't treated their sewage. A survey of about 200 different Russian rivers showed that about 80% are contaminated with sewage. That's 70% in India. In 1972, Clean Water Act, a very important piece of legislation in the U.S. Clean Water Act attempted to regulate water discharges, but with mixed success. New sewage treatment plants built since have saved about, in the United States and around the world, have saved about 80 million lives, it's estimated. With the gradual reduction of pollution into the lakes and streams, that has fixed a lot of problems over the years. The last 50 years, Clean Water Act has been successful in a lot of ways. Not entirely successful, but made some progress in a lot of areas. Classic example, Lake Erie. Off the coast of Ohio. Big port cities include Cleveland and Toledo, Detroit, major industrial cities. So what was happening was a bunch of industrial wastes are being dumped into Lake Erie and on into the 1950s and 1960s, particularly with Cleveland. Because Cleveland, one of its big industries is the oil industry. They have a lot of major oil refineries, and to refine oil into various useful substances, that takes a lot of different chemicals. And so they just dump that into the Cuyahoga River and all flowing into Lake Erie. The problem was so bad that, because remember, oil and benzene. Benzene's a product sometimes used with oil, transform oil into different products. Remember, it doesn't dissolve, so a lot of times it would be floating on top of the river. So you'd have all these contaminants on top of the river, and there actually were points in the early 1970s where the river in Cleveland was on fire. Flammable substances, somebody throws down a match or something, the top of the river is so choked with these flammable substances that don't break down in water that, yes, it caught on fire. There are actually pictures of this. Look at old Cleveland historical pictures. Go to pictures from a Cleveland newspaper, the Plain Dealer. River was on fire, and they said, we've got to do something about this. Lake Erie, by the early mid-1970s, it was considered a dead lake. So much pollution had been dumped into it that it was almost that life was almost entirely wiped out in Lake Erie. But people decided they were going to do something about it. Armed with the Clean Water Act and determination, began cleaning it up, began stopping the dumping of toxic substances into the lake. And that's the thing about pollution is, while some pollution is inevitable, the long-term effects the high amounts of it, it's a fixable problem. Something that can be fixed. We're not helpless. We don't have to live in a cave to avoid pollution. But modern technology, uh, treatment techniques can minimize the effect of pollution. And because of that, because of many years of working on Lake Erie, by the early 2000s, it was a thriving, clean lake again, useful for fishing and for recreation. Um, it's a healthy lake, and something that people of Ohio can be proud of. That they fixed the problem of water pollution in Lake Erie. It's no longer a dead lake. But it's still a problem in many other areas. Environmental Protection Agency estimated in 2005 that about half of all estuaries and 45% of lakes and 39% of streams in the United States were polluted to some extent. So that's the issue of water pollution. Next time we'll talk more about air pollution. And that'll be it for now.